All right, guys, we're going to go on and get started. If there are no questions on any of the assignments so far, what we're looking at today is properties of rational exponents, or properties of exponents, and simplifying them. Now, when we look at this here, we have several properties that we've already covered or kind of talked about or you've learned so far. The first one's product of a power. If we multiply two like bases together, we add the exponents. So if we multiply 5 to the 1/2 by 5 to the 3/2, we add the exponents together. Power of a power, a to the m to the n. When we have a power to a power, we multiply the exponents. So we have a to the m times n. When we have power of a product, we have two things multiplied together to an exponent. We apply that exponent to both bases. Negative exponents, a to the negative m. To make the exponent negative, positive, we move it from the numerator to denominator or denominator to the numerator. The zero exponent, a to the 0. Anything to the 0 power is 1 except for 0. Guys, let's face forward. The only one that doesn't work is 0. We cannot have 0 to the 0. Any other one does work. Our quotient powers. If we have two like bases being divided, we subtract the exponents. And lastly, power of a quotient. If we have two things divided to an exponent, we can apply that exponent to both numbers. Simplest form. So we have three main properties with this here to know if it is in simplest form. The first, no radicands have perfect nth powers as factors other than 1. That means we can't simplify it further than what we already have. So we can't leave a number as 4 to the 3/6. We can't leave it as this here because the 3/6 will reduce. It will simplify. Because this will be the same as 4 to the 1/2, which is actually just 2. Because our 1/2 power is the same as the square root, we could simplify it as this here. Or we could say that it is the same as 2 squared to the 1/2. Powers of powers multiply. Our 2 times 1/2 would be 1, which would give us 2. No radicands contain fractions. We can't have a radical with a fraction in it. And lastly, no radicals can appear in the denominator of a fraction. We can't have a radical. We cannot have a fractional exponent in the bottom of a fraction. And our other properties of exponents still hold true. We can't have negative exponents. We have to make sure that they are positive. And a lot of what we're going to do today and tomorrow and a lot of what is part of 5.2 is manipulating these expressions and getting them in simplest form. Now, not all of them will have a nice number answer. Some of them will, but most of them will not. And for most of those, we're going to leave it in fractional exponent form, in radical form, instead of turning them to a decimal. So the first one we're going to look at is this one here, 7 to the 1/4 times 7 to the 1/2. Because the bases are the same, we can add the exponents. We can add the 1/4 and 1/2 together. Now, if we were doing this by hand, we would have to get the bases to be the same for us to be able to add. But what we can do instead, 1/2 plus 1/4 is 3/4. So we get 7 to the 3/4. Now this here is as simplified as it gets. Bless you. Now some of the things we'd have to look into is seeing if we can rewrite 7 or rewrite the base as a perfect square, perfect cubed as a number times itself to be able to simplify it. But here, 7 to the 3/4 is as simplified as it gets. We don't do anything with it. Because if we tried to reduce this, 7 to the 3/4, we don't get a nice number. We get this ugly, or quote unquote ugly decimal. So for this here, 7 to the 3/4 is as simplified as it gets. Because if it asks us to round to the nearest tenth, to the nearest hundred, first or second decimal, then we would round. If it doesn't, we're going to leave it as this here. Any questions on the first one here? Now, let's look at the next one here. 6 to the 1/2 times 4 to the 1/3 to the second. So here, we're going to apply the second power to both. So we'll get 6 to the 1/2 times 2 times 4 to the 1/3 times 2. Our power of a product of a power. For the 6, well, we're going to do 1/2 times 2, and 1/2 times 2 is 1. So we can just leave it as 6 times 4. 1/3 times 2 is 2/3. Can we rewrite 6 as a number times itself? A certain number of times? Well, no. The only factors of 6 are what? 2 and 3. So that doesn't help us. Can we rewrite 4 as a number times itself? 2 squared, yes? Now for this one here, we can rewrite, so 6 times, replace 4 with 2 squared. And again, power of a power, multiply. So 2 times 2/3 is 4/3. Now for this one here, either one of these actually work. 6 times 4 to the 2/3 or 6 times 2 to the 4/3. Both of these work. Now the reason we would need to do this, to rewrite it as 2, is if rewriting it as 2 would have simplified that fraction. Because if it had been 3/2, do this in red. Because if it had been 2 squared to the 3/2, this would have made a difference, guys. If it had been to the 3/2, this would have made a difference because 2 times 3/2 is 6/2, which would have been 2 to the 3rd, which is 8. It would have actually simplified. You all see that there. So on some of these here, the fact that 4 squared, it will simplify, we need to simplify it. But because in the problem we have, the base, the bottom of the fraction is 3, even rewriting it as 2 doesn't simplify that 3. It doesn't reduce it down further. All right, guys, let's look at the next one. 4 to the 5th times 3 to the 5th, all to the negative 1/5. So again, the first thing we can do is apply this negative 1/5 to both, which just gives us 4 to the 5 times negative 1/5 times 3 to the 5 times negative 1/5. Now for our first one, 5 times negative 1/5 is negative 1. For the 3, the 5 times negative 1/5 is negative 1. But we can't leave an exponent negative, so to make it positive, we move it from the numerator to denominator, or denominator to numerator. So we move the 4 and 3 from the top of the fraction to the bottom to make the exponents positive. Any questions on this here? Can we actually do 4 times 3? Yeah. 12. So we get 1/12. Because both exponents were 1, when we moved into the bottom of the fraction, we could actually multiply them together. Now this is a little bit different than the one that we had before, 6 times 4 to the 2/3, because really what we're looking at is 6 times the 3rd root of 4 squared. We can't actually multiply those two together. Any questions on any of this here? Let's look at some more examples of these here. Now the next one we're looking at is 5 over 5 to the 1/3. Because 5 in the top and bottom of the fraction, the bases are the same, we can subtract the exponents. Now the exponent on top is 1. The exponent on bottom is 1/3. Now at this point here, we can do 1 minus 1/3, and 1 minus 1/3 is 2/3. Now we could have also done that in a calculator, 1 minus 1/3, and gotten 2/3. Now since 5 is prime, there's no way we can rewrite it as a number times itself. So this is as far as it goes. Any other questions on number D? Now let's look at letter E. So we have 42 to the 1/3 divided by 6 to the 1/3, all to the 2nd power. Now we can't do what we did on the previous one because 42 and 6 are not like terms. They're not like bases. So we can't just subtract the exponents. But will 42 divide by 6 evenly? Will 42 divide by 6 evenly? Yes. Now, one of the properties that we had, quotient of a power, said that if we have a divided by b to the m, that's the same as a to the m over b to the m. We can go in either direction. Now, the reason we would do this, and the reason that we're going to do this, is we can take, we can pull that 1/3 power away because the numerator and denominator both have the same exponent being applied to it. We can remove it from it. A to the m over b to the m is equal to the same as a over b to the m. And the reason we do this is because, as we already saw, 42 divided by 6 is 7. And we need to simplify this because we cannot have a fractional exponent in the bottom of a fraction. And since 42 divided by 6, 42 divides by 6 evenly, we can pull that 1/3 away, divide the 42 and 6, and get 7. And to finish this off, we just multiply our exponents back together. So we have 1 times 1/3, which is just 1/3, times 2 is 2/3. Now we won't talk about it in this one here, but if the 42 and 6 had not divided evenly, we have to do a different method to get there. And we'll cover that later. We won't cover that today. Any other questions on anything we've done so far? Now again, a lot of what we're doing today and in 5.2 is going to be really manipulating these numbers so that we get something that's nicer to work with. Next one, we're looking at 2 to the 3/4 times 2 to the 1/2. Since the bases are the same, we're going to add the exponents together. 2 to the 5/4. Because again, in a calculator, we can do 3/4 plus 1/2 and get 5/4. So that there is as simplified as it gets. We can't reduce it any further than that there. For the next one, we have 3 over 3 to the 1/4. Since the bases are the same, we can subtract the exponents. So the exponent on top is so we're going to do 1 minus 1/4, which is is 3/4. So we get 3 to the 3/4. Since 3 is prime, there's nothing we can do with this here. That is simplified as it gets. Any questions on any of these here? Let's look at the next one. So we have 20 to the 1/2 divided by 5 to the 1/2, all to the third. Do 20 and 5 divide evenly? All right, guys. So we have 20 over 5, which does indeed reduce to 4. Now we can multiply our exponents together, which would give us 4 to the 3/2. But before we say this is officially finished, can we rewrite 4 as a number times itself? 2 squared. Now here, so we have 2 squared to the 3/2. Well, 2 times 3/2 is, so we do 2 times 3/2, which gives us 3. And 2 to the third is, because 2 squared is 4, multiply by 2 one more time, we get 8. Now, since it gave us a nice number, it means we could have actually plugged the original problem into the calculator and it would have given us the answer. But on some of these here, we don't know that until we actually simplify it out or work it out. So we have 20 to the 1/2 over 5 to the 1/2 all to the third would have given us 8. Now, if we still had a fractional exponent, it would have given us a decimal instead. Questions on any of this here? Now the next one, our first step is going to be to apply that power of 3 to both the 5 and the 7. And when we multiply it by the 5, we get 5 to the 1/3 times 3 times 7 to the 1/4 times 3. Now our 5, well, 1/3 times 3 is 1. So we just have 5 to the first. Now the 7, 1/4 times 3 is 3/4. So we get 5 times 7 to the 3/4. And that's it, because the 7 can't be rewritten as a number times itself. This is as simplified as it gets. Any questions on any of this here? We ready for the next one? Three to the 1/2 times 3 to the 3/2. Since the bases are the same, we add the exponents. Well, 1/2 plus 3/2 is 2. Because 1/2 plus 3/2 would give us 4/2, and 4/2 is indeed 2. Can we simplify 3 squared? It'd be 9. Because if we can simplify it, we're going to need to simplify it. For the next one, 7 to the 2/3 times 7 to the 1/2. Whenever we multiply like bases, we add the exponents. So we're going to add 2/3 plus 1/2, which gives us 7/6. And again, 2/3 plus 1/2, we can add those in a calculator. Any questions on any of this here? Ten to the 1/2 divided by 10 to the 1/4. Since we have like bases, we will subtract the exponents. When we multiply like bases, we add. When we divide like bases, we subtract. So 1/2 exactly minus 1/4 is, guys, 1/4. Four to the 3/2 squared. I think at this point you all have gotten most of these down because we'd multiply. So it'd be 4 to the 3/2 times 2, which is 4 to the, and 4 to the 3rd is 64. Now 4 to the 3/2 squared, we could have plugged this in a calculator because 64 is a nice number. It would simplify it for us. (25 to the negative 1/2). Well, if we wanted to, we could try it in a calculator and see. (25 to the negative 1/2 is 1/5). Now, we can't always use the calculator, but we can on some of them. Now, to make the exponent positive, we move it from the numerator to the denominator. So we get 1 over 25 to the 1/2. Now, 25 is a perfect square. It would be what? Because 25 is the same as 5 squared. Our squared times 1/2 would be 1, leaving us with 1/5. Any questions on any of this here? Yes. Now let's look at the next one. 12 to the 1/6 over 3 to the 1/6, all to the fourth. Now because 12 over 3 does reduce nicely, and they're both to the 1/6 exponent, we can pull the 1/6 exponent away, leaving us with 12 over 3. Now 12 divided by 3 is 4. Now we can multiply our exponents. 4 times 1/6 is going to be 4/6. Now 4/6 will reduce to 2/3. Now this here realistically is as simplified as it gets for the most part, but could we rewrite 4 as a number times itself? Which would give us 2 to the 4/3. But since the 2, rewriting it as 2, didn't really reduce that exponent, it really didn't matter which one we left it as. But it is still sometimes good to see if it would actually reduce it or not. Because if it does reduce it, we need to reduce it. If it doesn't make a difference either way. Any questions on these here? Are you ready for the next one? I believe we only have 3 left, and then we are done with the notes for today. Now C, if we look at this here, we have both of these applied to the negative 1/3 power, yes? What do we know? How can we make the negative 1/3 power positive? Move it from the numerator to the... So if we wanted to, we could actually start off by moving the whole thing to the bottom of the fraction from the beginning. And that is a 2, yes. Guys. Now we can multiply both of these by 1/3. 4, 3 times 1/3 is 1. 2's 3 times 1/3 is 1, which gives us 1/8. Questions on this here? Now, one of the interesting things, this isn't listed here, with negative exponents, I'll show you this here, because if we had 3 over 4 to the negative second power, we could apply that negative second power to the top and bottom and then simplify, but this is the same as 4/3 squared. If we have a quotient to a negative power, we can flip the quotient and apply that power to it. Because if we did it the other way and just applied the -2 to it, we'd have 3 to the -2 over 4 to the -2. To make the 4 exponent positive, we would move it to the numerator. To make the 3's exponent positive, we'd move it to the denominator, which would give us the exact same thing. Any other questions on any of this here? Now, if we look at this next one here, 27 to the 1/3, can we simplify 27 to the 1/3? Yeah. And it would be? What's 27 divided by 12? What are the factors of 27? So what's one number that goes into 27? 9 and 3. 3 is... So 27 is the same as 3 third. Now, guys, this is important because we have 3 to the third to the 1/3. And our 1/3 and third power with the 3 is just going to be 3, because 27 to the 1/3 is 3. And if we plug it in the calculator, we'll see that it's also 3. Since it is reducible, we need to reduce it. Now, the last thing we need to do is apply this 2 to both terms, which would give us 3 squared times 6 to the 1/4 times 2. 3 squared would be 9, and we'd have 6 to the 1/2. Any questions on any of this here? Your homework is on page 252, problems 3 through 10.